Well, now we are back into the 5th lockdown in Victoria again. So I think it will be worthwhile to use this valuable time going through the recent Northern Hemisphere timetable exam for specialist math. Last time I think I did my solution for the exam 1, so this time let's get started with the paper 2. Well, let's start with the multi-choice questions. The graph of y equals cosine inverse 2 minus bx, where b is a positive real constant, could be. Okay, I would say let's start with b equals minus 2. Oh, hang on a second, 2. Positive real constant. So I'm going to sketch this one on my CAS calculator. Cosine inverse 2 minus 2x. Let's start with a fresh, brand new page. Graph. Cosine inverse 2 minus 2x. Okay, so this looks like option A. Easy. All right. Consider the function with the rule f of x equals absolute x minus 3 plus absolute value x plus 3 minus 8, where a is a real constant. The graph of 1 over f of x will have 3 asymptotes if the set of values of a is. I could have used slider. Let's try graphs. And I will directly draw this guy here, 1 over absolute value x minus 3 plus absolute value x plus 3. And don't forget my minus a. Enter. Now I need to create a slider for a. So by varying the values of a, I could see the pattern of the reciprocal graph. All right, so now I can take a look at the slider here. When a equals 1, I believe the graph is asymptotic to y equals 0. So there is only one horizontal asymptote. If I change the value, let's say, when a equals 5. All right, if a equals 5, still one horizontal asymptote, maybe I should do some setting with this one. Let's try to use other different values. Settings. Let's say the minimum is minus 5. The maximum, let's say 10. Step size, let's say is 0.25. Okay. So now let's look at the difference. Oh, see, when a equals 6, there could be 2 vertical asymptotes, roughly here or here. So x equals 3 or x equals minus 3. How about bigger value for a? Ah, I see. So a is going to be bigger than or equal to 6. This is a new question. Very good question. Slider. One thing I'm going to comment on, when you have used a slider, let's say you have a letter A here. In the same problem on your CAS calculator, the A is defined in the previous page. So make sure you do something like actions, clear A to Z. Now the letter A is not defined anymore. All right, so let's look at the next question. Question 3, okay, reciprocal graph again. 1 over x squared plus sx plus t. no vertical asymptote. So the delta will be s squared minus 4 times 1 times t, which is less than 0. It gives no solution for the denominator. So now I have s squared less than 4t. S squared over t is less than t. T is greater than s squared over 4. So let's choose option C. Question 4. The expression ax plus b over 2x minus 1's whole thing squared times x plus 1 has a partial fraction form. All right, 3 pieces. We want to find the values of a and b. All right, so instead of doing the partial fraction decomposition, I'm actually combining the 3 terms back into this form. So let's use my CAS calculator, Algebra, fraction tools, I believe, and common denominator. So I'm putting the 3 terms one by one. 1 over x plus 1. Take away 2 over 2x minus 1. And finally, take away 1 over 2x minus 1 squared. Okay, so I have 2 minus 7x on the top. So this bit will be minus 7x plus 2 over 2x minus 1 squared times x plus 1. And the value of a is minus 1, b is 2. So we choose option D. Fairly easy. Question 5. The complex number z equals b plus i. B is a real number, has the property of argument z to the power of 7 equals argument z. A possible value of b could be, let's say, okay, argument in my CAS calculator, I can use the syntax angle, okay? So angle z to the power of 7 should be b plus I to the power of 7 equals angle b plus I itself. So now I'm looking for the value of b if it's possible. You could try to use solve, but here I'm not solving for the value of b. Instead, I'm testing the equivalence for this whole expression. The left-hand side is angle b plus I to the power of 7 equals. If you want to know where to access angle, you could go for manual number, complex number tools, and polar angle. Then you go for b plus I, okay? Ignore the capital B. Then I should sub in each option. Let's start with the first one. The first one is minus root 3. Let's try with b equals minus root 3. False. So the left-hand side is not equal to the right-hand side. Let's paste the history, but change the last bit. If b is 0, it's still not true. So I'm going to the third option, which is C. B equals 3. Now, actually 1 over root 3. Yep, that's true. So option C is correct. Question 6. If z is a non-zero complex number, then cosine argument z is equal to. Notice that they have a small argument here, which means it could be going beyond minus pi to pi, okay? In this question, I'm going to draw a little diagram, I believe. So this axis is real axis. The vertical axis is your imaginary axis. Let's say you have a random complex number here. This is your z equals x plus yi, right? So which part is your argument z? It's the theta here, okay? Breaking that into two pieces, that's your x and that is your y. So your cosine theta, which is cosine argument z, will be x over r. What is your x? X is your real part. And your r will be your absolute value of z, which is the length of the complex number here. So now I'm using this one to match each option and see which option is appropriate. The first one, it's absolute value of real z over z. But if the complex number z is in the second quadrant, or let's say in the third quadrant, z, real z could be negative. So we can't let the absolute value to get only positive value here. So I'm going to cross that one out. The next one, it's real z on the top over square root of z times z bar. What is z times z bar? By definition, it's x plus yi times x minus yi, which gives you x squared plus y squared. So taking the square root means, okay, you are taking the square root of x squared plus y squared, which is exactly the length of complex number z. So I believe option B is correct. And I don't need to take a look at the remaining three options. Question 7, with a suitable substitution, the integral can be expressed as, So if you have ever seen a fraction instruction in your integral, you might take a look at the bottom. In this case, I would say u is sine 2x. So the u dx will be 2 cos 2x, which is twice the numerator. So now I can combine these two to become half du. Okay, and then don't forget to change your terminal. When x equals pi on 12, your corresponding u value will be sine pi on 6, which is half. When x equals pi on 6, the u value will be sine twice pi on 6, which is pi on 3. This gives you root 3 on 2. So your integral will be half to root 3 on 2. And the top will be 1 over 2 du dx. The bottom will be u squared dx. This will be half to half root 3, half in the front, 1 over u squared du. So option A is the correct option. Let's look at the next one. The differential equation that has the diagram above as its direction field. Looks like it's a rotated ellipse. So let's say if it passes through 2, 0, a possible solution to this slope field could look like that. I'm just draw a line of best fit. Looks like that, right? So now I'm going to incorporate my arbitrary initial condition to 0 with one of the options and sketch it on the CAS calculator. Normally, I'll start with the first one or the last one. Let's try our luck with the last one. The last one is 4x minus y over x minus 4y. So add a graph and change it to differential equation by pressing menu 3-8. You probably want to delete the 1 after y, okay? So, okay, 4x minus y. The bottom should be x minus 4y. Okay. So now If you incorporate 2, 0, what will happen? Ah, looks like that. I would say this one matches our sketch on the paper pretty well. Option E should be feasible. Do we have other techniques to check if our sketch is correct? Well, yes, we have. You could say, you could de-solve differential equation solver for this one. dy dx is y dash equals 4x minus y divided by x minus 4y. If you incorporate y of 2 is 0, comma x, comma y. Let's see what happens. Manual calculus differential equation solver. The DE is y dash equals bracket 4x minus y bracket over x minus 4y. Independent variable is x, dependent variable is y. Your condition is y of 2 equals 0 at your choice. Okay. Required field is empty. Let's have a look. What is the required field? Field 1 equation shouldn't be empty. That's weird. Okay, it doesn't allow me to put it in that way, so I'm going to do it manually. De-solve. Paste. Space and space. Y. Hold on a second. What's going wrong with my... Let's do it again. Y dash equals 4x minus y, x minus 4y, and y of 2 is 0, comma x, comma y. Okay, so here we have our relation. To sketch that, I can add in a graph page and change the graph entry to relation. Paste. Yep, that looks perfect. A rotated ellipse. So option E is a good option. Question 9. Consider the differential equation dy dx equals 2x plus 1, where y of x0 is y0. We want to use Euler's method with step size h to get y2. This time we cannot use our Euler command on CAS calculator, so I'm going to derive it manually, but finally we're going to use our CAS calculator. So let's say, let f of x equals dy dx, which is 2x plus 1. When x equals x0, y equals y0. So y1 will be y0 plus the increment, which is step size h, times dy dx at previous point. In this case, it's f of x0, right? And your x1 should be x0 plus h. And then y2, by the second iteration, you will get y1 plus h times f of x1. So I'm going to do exactly the same procedure on my CAS calculator. Add a calculator, define f of x equals 2x plus 1. And define x1 equals x0 plus h. Define y1 is y0 plus h times f of x0. Okay, so y2 equals y1 plus h times f of x1. Looks like this is our final output. So I'm going to expand the output for y2. So it will be 2h squared plus 4hx0 plus 2h plus y0. Let's compare the option. Option A will be your correct option, okay? So this is also easily done by CAS calculator as long as you understand how Euler's method works. All right, so question 10. A tank initially contains 20 liters of water in which 0.25 kilograms of salt is dissolved. So V0 equals 20 liters. X of 0 is 0.25 kilograms. Fresh water flows in at a rate of 6 liters per minute. So dV dt in is 6 liters per minute. How about the concentration in? Because it's flowing in fresh water. Okay, concentration in is 0. Flowing out, your C out is unknown. Your dV dt out is 8 liters per minute. Before I derive my total differential equation, I'm going to write C out is the mass over volume. Your volume is 20 liters plus flow in 6, flow out 8. 6 minus 8 times T. So it's X over 20 minus 2T. Now your differential equation will be dx dt equals to C in times dV dt in minus C out times dV dt out. Concentration in is 0 times 6 minus 8 times x over 20 minus 2t. In this case, it will be minus 8 on x, 20 minus 2t. And you can cancel a common factor 2, minus 4x over 10 minus t. This should be correct. And let's tidy it up. The x dt will be 4x over t minus 10 if you wish to write it in that way. And finally, I'm going to separate the variables. So it will be x1 over x dx integral equals 4 over t minus 10 dt. This should be option D. Alrighty, so that's how we derive the relation between x and t using separation of variables. You need to know your concentration out and the way to derive dx dt by doing rate in minus rate out, okay? Question 11, let A and B, two vectors, be arbitrary non-zero vectors. Which one of the following statements is always true? So let's look at each option. A plus B absolute value greater than or equal to A minus B absolute value. All right. Let's start with two arbitrary vectors. This one is A. This one is B. I'm going to recall the basic addition property of two vectors. If you add two vectors up, A and B, the main diagonal of this parallelogram will be your resultant vector A plus B. I'm pretty sure the sum of this length and that length will be greater than this bit. Extreme case, if A and B are in the same direction, let's say They look like that. The final product will be the length of A in this direction plus vector B here. So the whole thing will be A plus B. In this case, the sum of length B and A will be equal to the length of A plus B itself. This is called the triangular inequality. So I'm going to write A plus B is greater than or equal to A plus B in an absolute value. So now, let's say, how about A absolute value plus minus B in the absolute value? Okay, this is also true because the absolute value will cancel the minus sign in the front. So this will be greater than or equal to A plus minus B in the bracket. Basically, it gives you A plus B, all in absolute value, greater than or equal to A minus B. So I should say, okay, option B is correct. If you are interested in a relevant derivation, it's called triangular inequality. You can Google it. A tricky vector question, mostly conceptual problems. Let's look at question 12. A particle has position vector r of t is t cubed times I plus 3t squared times j. The total distance traveled by the particle from t equals 1 to t equals 4. So dx dt is the derivative of this guy, 3t squared. And dy dt, the derivative of 3t squared will give you 60. So the arc length, which is your distance traveled, is t equals 1 to t equals 4 in an integral square root dx dt squared, which is 9t to the power of 4 plus 60 squared, 36t squared dt. By calculating this integral, you could get the value of the arc length. So integral 1 to 4 square root of 90 to the power of 4 plus 36t to the power of 2 dt, and you are calculating the numerical integral, so it's 78.26. Looks like the last option. All right, so question 12, pretty easy, straightforward. Question 13, the scalar resolute of A in the direction of B. So I'm going to calculate A dot B hat, which is A dot B over absolute value of B. A dot B, 1 times 4, minus 2 minus 4. 1 times 7. And length of B is given by 4 squared plus minus 4 squared, which is also 4 squared plus 7 squared. The top will be 4 plus 8 plus 7. This should be give you 19. And the bottom will be 16 plus 16 plus 49. This will be 81. Square root of 81. So this will be 19 over 9. So this is the magnitude of your scalar resolute. Option D. A jet of mass 80,000 kilograms accelerates from rest in a straight line along a horizontal runway to takeoff speed of 75 meters per second. So it accelerates to this point, and V equals 75 meters per second. The thrust force of the engine is 200,000 newtons, and the resistance force acting on a jet total 100 V newtons. V is the speed. So let's do a free body force diagram. So this is 80,000 G. It's along the horizontal runway. So this is the reaction force. Up until this point, we still have the reaction force and the gravitational force 80,000 G. The thrust force should be in the direction of the motion. And finally, we have the resistance force, 100 V. So from the start to the end, the force diagram applies, and we want to find this distance. Let's say this position has x equals 0. This position has x equals d. Notice that we can't use suva here because it's a variable force, which means you have a variable acceleration in terms of v. F net is the driving force, which is a thrust. Take away 100 V, the resistive force, equals the mass 80,000 times acceleration. So A equals 100. 2,000, take away V divided by 800. Now we have velocity or speed and position or distance. So I'm going to use V times dV dx to do the following calculus stuff. If you separate the variables, you have 2,000 take away V over 200 V equals dV dx. Flip that around, you get a dx dV equals 800 V over 2,000 take away V. You have two sets of conditions. V equals 0 corresponds to x equals 0. V equals 75 corresponds to x equals d. So if you anti-derive the differential equation here, you will get 0 to d, 1 dx equals 0 to 75, because you are accelerating, your velocity goes from smaller to a larger value. 800 V, 2,000 minus V dV. So here is your final stuff. I'm going to use my CAS calculator, do the calculation. Left-hand side, 0 to D, 1 dx equals antiderivative 0 to 75. The top is 800 V. The bottom is 2,000 take away V dV. And this is the exact answer, but I just need a decimal approximation. 1153.94, which is 1154 meters. Looks like option B is correct. Okay. Question 15. Three masses M1, M2, and M3 kilograms attached by light and extensible springs hanging in equilibrium over a smooth pulley. Equilibrium, that's the key word. So the net force is 0. Tensions of magnitude T1 and T2 newtons are present in the strings as shown in the diagram below. So let's complete the force diagram. Definitely we should have a gravitational force M1G here, as well as M2G acting on the M2 kilogram mass. And M3 is here, M3G. So now let's use each object to do the equation of motion. So for the first one is T1 equals M1G. That's pretty straightforward. And we should have another T1, which is here, equals the sum of M2G and the T2 here. And the last one, T2 equals M3G. All right. Looks like we only have T1 and the T2 unknown in the system of 3 equations. In this case, I'm going to use my CAS calculator to solve the system of equations. Let's say algebra, solve system of equations, and solve system of equations. We have 3 equations, but we only have 2 variables, T1, T2. Okay, so the first one is tension 1 equals M1 times G. Tension 1 is also equal to M2 times G plus T1. The last one is T2 equals M3 times G. So now I have GM1 equals G times M2 plus M3, and T1 equals GM1, and T2 equals G times M3. So let's take a screenshot of this result and compare it with the options. It's here. Finally, we want to find the ratio between T2 and T1. So if T1 is GM1 and GM1 is this guy here, so T1 equals G times M2 plus M3. And the T2 is G times M3. So I would say T2 over T1 is G times M3 over G times M2 plus M3. Okay, so this will be M3 over M2 plus M3. But we don't have such an option. So I'm going to say, okay, since M1 times G equals M2 plus M3 times G, M1 equals M2 plus M3. We can say M3 is M1 minus M2. All right, so I'm going to put M1 minus M2 here. M1 minus M2 is here, and M1 is here. Option E. What a tedious algebra problem rather than a mechanics problem. It's all about manipulating the expressions using what you have on your plate. Question 16. A particle of mass 2 kg has a horizontal velocity component of magnitude 12 meters per second. Horizontal component 12 meters per second and vertical velocity component 5 meters per second. Roughly that long. The magnitude of the momentum. So let's talk about the resultant velocity. The resultant velocity I would say is 12I plus 5J. The magnitude of the resultant velocity should be 13, okay? Because you just used your Pythagorean triad. 5 squared plus 12 squared, which should give you 13 squared. Take a square root, gives you 13 meters per second. So the magnitude of the momentum will be mass times the speed, which is 2 times 13, 26 kilograms meters per second. Not bad. A particle moves in a straight line at time t seconds. Its displacement x meters from the origin and its velocity v meters per second are such that v equals 9 plus x squared. You have t, you have x. Initially, x is 3 meters, t equals 0, x equals 3. dx dt is your velocity, equals to 9 plus x squared. So dt dx will be 1 over 3 squared plus x squared. Anti-deriving, you get that expression. Your t should be 1/3 tangent inverse x over 3 plus c. And t equals 0, x equals 3. 0 is 1 over 3 tangent inverse 1 plus c. So c is minus 1 over 3 times quarter pi, which is minus pi on 12. So t is 1 over 3 tangent inverse x over 3, take away pi on 12. Option C is correct. T is equal to, okay? Of course, you could also use d-solve. In d-solve, you're gonna put x dash equals 9 plus x squared. Space and space. x0 is 3, comma t, comma x. And it should give you a similar expression to that one as well. Finally, it's been a long time not seeing any new probability and statistic questions. And this is a good one. It is believed that the average lifespan of people in Okinawa, I think it's a city in Japan, I suppose, is 80 years. So this is my mu0, 80. A random sample of the lifespans of 200 of these people, so this is my n sample size, has an average of 84 years. You never confuse this number with your population mean. 80 years is your claimed population mean. So this guy here, 84, it's not mu0, it's x bar, your sample average or sample mean. X bar is 84. A one-tailed statistical test using 5% level of significance, that's your alpha, which is also your probability of type 1 error. Okay, so we want to use this test to test if the actual lifespan is greater than 80 years. So I'm using H0 mu equals mu0, whereas your alternative or hypothesis is H1 mu is actually greater than the claimed value. So in this case, mu equals 80 against mu greater than 80. That's it. So the correct answer is option E. Make sure in similar questions, you are looking at the keywords, one-tailed statistical test or two-tailed, okay? And you look at the keywords like greater than, smaller than, not equal to, increased, decreased. And finally, most importantly, make sure you differentiate between the two terms, population mean, which is your mu0, and your sample mean, okay? This is your test statistic. This is your reference number. Question 19. X and Y are independent random variables with variance 3 and 7 respectively. Given the random variable z equals 2x minus 3y plus 5, the standard deviation of z is closest to. Never ever work out standard deviation directly. You always want to find the total variance or combined variance first. So your combined variance z is the combined variance of 2x minus 3y plus 5. Notice that your variance of any constant is 0. It's different from adding the constant for mean value or expected value. So you got to be careful with that. So now I'm taking out a 2 and square it. 2 squared variance of x plus, not minus, minus 3 squared variance y plus variance 5, and this is 0. So this gives you 4 times variance x, which is 3, plus 9 times 7. And this should give you 12 plus 63, which is 75. Since your variance is 75, your standard deviation will be the square root of that. I suppose it's 5 times root 3, if I'm not mistaken. Should be 8.66 something. Let me double check. Well, I'm correct. 8.66. Question 20. In order to gain an accurate assessment of a patient's blood pressure, a doctor asks the patient to take 16 blood pressure readings. N equals 16. The readings are measured in millimeters of mercury. The mean and the standard deviation of these readings, X bar is 125 easy, and S is 10. And also sigma is 10. Assuming the patient's blood pressure reading are normally distributed with mean, mu, and width, sigma equals 10. A 99% confidence interval. Okay, C level is 0.99. We want to find the confidence interval for sample mean, and let's go back to the calculator and choose menu 6 statistics, 6 confidence intervals, and choose the first one, Z interval. Change this one to stat. Press OK. Your sigma is 10. Your X bar is 125. Your N value, you have 16 samples. Don't forget to change the last one, C level, 0.99, because it's 99% instead of 95%. Press OK and Control Enter. 118.56, 131.439, which is 0.44. Okay, so looks like option B is the correct option, correct 1 decimal place. Okay, and that concludes the 20 multi-choice questions. Let's move on to the 6 extended response question later. Okay, here comes my solutions to section B. Instructions for section B. Answer all questions in the space provided. Yes. I have nowhere else to answer my questions. Unless otherwise specified, an exact answer is required to a question. Yep. Fraction, log, exponential, square roots, etc., etc. In questions where more than 1 mark is available, appropriate working must be shown. Yes, of course, I need to show my working to get full marks. Unless otherwise indicated, the diagrams in the book are not drawn to scale. Not always, but let's stick to this rule. Take the acceleration due to gravity to have magnitude g meters per squared second, where g equals 9.8. Yep, we can't use g equals 10 unless it's implied by the question. Let's look at question 1. A curve is defined parametrically by x equals secant t, y equals cosecant t, where t goes from 0 to pi on 2, both exclusive. Show that a curve can be represented in Cartesian form by the relation y equals x over root x squared minus 1. So it is the safest approach to derive the Cartesian relation from scratch. Normally, with anything involving circular functions, I would try to add x squared and y squared. So this will be secant squared t plus cosecant squared t. If you have no hint at all, you could try to recall from first principle. This should be cosine squared of t plus 1 over sine squared of t. You should know that from year 11. I don't like them to be written as two individual terms. Instead, I'd like to combine them, which is taking the common denominator. So this will be cosine squared t times sine squared t. The first one will be multiplied by sine squared t. The second term will be multiplied by cosine squared t. So what is that? Sine squared plus cosine squared, which is 1. So now I have cosine squared t times sine squared t. You should notice that that is exactly secant squared t times cosecant squared t. Therefore, we know x squared plus y squared is actually x squared times y squared. So now I'm going to isolate the y terms. X squared equals to x squared times y squared, take away y squared. And x squared will be y squared out, x squared minus 1. And y squared will therefore be x squared divided by x squared minus 1. But then we realize for t goes from 0 to pi on 2, my x value must be greater than 0 because it's in first quadrant. Y is also greater than 0. So taking the square root will give you the required Cartesian equation. X squared becomes x. Y squared becomes y. And the bottom is square root x squared minus 1. This is how you're supposed to derive the given Cartesian relation, okay? If you try to substitute this one into the left-hand side and this one into the right-hand side, well, it could be more efficient, but probably not the safest approach, okay? So let's look at the second part. State the domain and range of the relation given by this guy here. So the domain and range are actually given by these two relations, okay? You should notice the domain for this parameter from 0 to pi on 2. Let's look at this guy here. Instead, I should draw x instead of y. Copy, paste. If you take a look at the graph of secant, it looks like that, 0 to 0, 1, open circle to infinity. So this is t equals half pi. And that's x equals secant t. How about the next one? Y equals cosecant t. This is t equals pi. This is t equals 0. The full graph should look like that, but I only have half of the U shape. This is half pi. This is 1. So the domain is given by x goes from 1 to infinity. The range is y is an element of 1 to infinity as well. Okay, use the derivative of the relation to show that a gradient of the curve is negative at all points on the curve. So let's call for our magic CAS calculator. Thank you, TI Inspire. The derivative of what? X over square root x squared minus 1. Okie dokie. So it's negative 1 over x squared minus 1 to the power of 1.5. Let's write y equals x over square root x squared minus 1. That gives you the derivative of dy dx. So it's minus 1 over x squared minus 1 to the power of 3 on 2. Now let's talk about the domain of that one. Since x goes from 1 to infinity, x is actually greater than 1. So x squared minus 1 must always greater than 0. And x squared minus 1 to the power of 3/2 is also greater than 0. Therefore, dy dx equals minus 1. A negative number divided by a positive number must be negative for all x goes from 1 to infinity. Okay, I believe I completed what I need to do for this question. Get the derivative expression and show the gradient of the curve is negative at all points on the curve within its domain, okay? Of course, you could also use the parametric differentiation. I suppose your x value is secant of t. Your y is cosecant of t. Using your CAS calculator, you could get dx dt. That is secant t times tangent t. Your dy dt is minus cosecant t times cotangent of t. So your dy dx will eventually be dy dt times dt dx. That should give you minus cosine cubed t of sine cubed t. For all t values goes from 0 to half pi. Cosine cubed t greater than 0 and sine cubed t greater than 0. But dy dt is negative, that guy, less than 0. Therefore, the gradient is always negative for all points on the curve. That could be another possible approach, but let's move on to the next part. Sketch the graph of the relation on the axis below, labeling any asymptotes with their equations. So if you take a look at your TI Inspire and sketch the graph, x over square root x squared minus 1. And you only take anything greater than 1. So you just need the first quotient part instead of both quotients, okay? To sketch that curve, you must make sure your sketch is accurate. That is your first thing you're gonna draw. X equals 1, vertical asymptote. Another bit, y equals 1. Y equals 1, that is your horizontal asymptote. The graph should look like that, and it's very close to the asymptote at the later stage, okay? Probably not very asymptotic to address the requirement, but that's the best thing, the best version I could do on my iPad. So in your sketch, make sure you draw it like a smooth curve, and your graph is getting closer and closer to your asymptote, okay? Not swirl away or run parallel to the asymptotes. Probably I should fix that. Let me switch to a thinner pen and see if I could have done it. I could have done it better. Jesus, that graph is very hard to sketch. Okay, I think that's the best version I could draw on my iPad. Let's move on to the next one. Write down a definite integral in terms of x, which gives the arc length of the curve from point 1 to 4. This time I'm using integral with respect to x. So arc length is 1.5 to 4. Square root of 1 plus the squared derivative. So it's minus 1 over x squared minus 1 to the power of 3 over 2 squared dx. You could leave your answer like that, but if you want to tidy it up, that's fine. It should give you 1 plus 1 over x squared minus 1 to the power of 3 dx. Don't forget the dx here, okay? It's very crucial. The arc length, if you calculate that one, arc length. Which function is that one? Okay, f3 of x. f3 of x, comma x, comma 1.5, comma 4. So this is the simplified arc length expression, and Control Enter 2.54. Corrected 2 decimal places. So question 1 finished. Question 2, a complex number. Points O, U, W are in the complex plane, representing the complex numbers 0, U, and W respectively. Argument U equals theta. When plotted on the Argand diagram, the points are the vertices of an equilateral triangle. Equilateral triangle. So OW equals WU equals OU, and this angle here is pi on 3, or 60 degrees. Now I want to express W in polar form in terms of L and theta. So this is L, this is L, this is also L. The W is positioned here. The length is W, the angle relative to the positive real axis is pi on 3 plus theta. So W equals L C's theta plus pi on 3, okay? Alternatively, if you write it in this way, W equals L times e to the power of I times theta plus pi on 3. This is also a polar form. Point P represents the complex number P and is the midpoint of U and W. Where is point P? Let me get rid of this notation. Delete. Midpoint between U and W, so it's roughly here. This is P. And it's along the angle bisector between the OW and the OU. If you use some right angle triangle trigonometry, I suspect, let's say, maybe I should illustrate the problem clearer with another triangle. So here is a duplicate of the equilateral triangle extracted from the diagram. If your midpoint P between W and U is here, let's say this is pi on 6, this is pi on 6, okay? This is L. The adjacent must be √3 on 2L. The opposite must be half L, okay? You are using the special ratio for a 30-degree right-angle triangle. So the length of P relative to O is here, which is √3 on 2L. And the angle is theta plus the 30 degrees here, which is pi on 6. So distance, let's say absolute value of P. Absolute value of P is L times cosine 30 degrees, which is √3 on 2L. My argument, P, should be theta plus pi on 6. Therefore, P in polar form is √3 on 2L times 6 theta plus pi on 6. Easy. And then you want to express P to the power of 12 in the form of A over B times U to the power of N. A, B, N are integers. Look at the mark allocation here. It will be a sensible idea to demonstrate some by hand working nouns, okay? So P to the power of 12 is the answer you obtained in part 1 to the power of 12, okay? So now, you should have √3 on 2 to the power of 12 times L to the power of 12 times C, 12 theta plus 12 pi over 6. And this should be √3 on 2, 12 times L to the power of 12, C, 12 theta plus 2 pi. Anything in an angle adding a 2 pi or a multiple of 2 pi will return to the original position. So this guy here is 12 theta, okay? You can get rid of the 2 pi here. It will be a good idea to calculate this speed by your CAST calculator. And this guy here, I could return it to C theta to the power of 12. And let's see. A bracket, √3 over 2 to the power of 12. 729 over 4096. So this guy here should be 729 over 4096 times U to the power of 12. Okay? Where is U? U is here. The angle is theta here, okay? So this is our required answer. A equals 729, B equals 4096, and N equals 12. All right, show that W over U is half plus root 3 on 2i. Let's have a look. W is, okay, L sees theta plus pi on 3. U is L sees theta. So W over U is L sees theta plus pi on 3 divided by L sees theta. This will be sees theta plus pi on 3 because the moduli cancel each other. Take away theta. So this will be sees pi on 3. And this will give you half plus root 3 on 2i. Okay? Oh, so much for 1 mark. Or maybe 1 extra step. Cosine pi on 3 plus I times sine pi on 3. That should be sufficient. Point U has coordinate a, 17, and the point W has coordinate b, 41. Find the values of A and B. Okay, so W over U is this guy here. It's always true. A 17, B 41. Okay, I got it. So let U be A plus 17i. W be B plus 41i. Using the Cartesian form of that point. And A plus 17i over B plus 41i equals half plus half root 3i. That is one possible equation. We have 2 constant. Do we need another condition? Yep, that's one equation. Also, OUW is equilateral. Yep. So distance OU is equal to distance OW. So A squared plus 17 squared equals B squared plus 41 squared. That's equation 2. You could have square roots on both sides, but once you square them, the square roots disappear, okay? So we are solving equation 1 and 2. Now, let's use the CAS calculator to solve them. In this case, I'm going to call for complex solve, C-solve, because we have some expressions involving i's, okay? Complex unit I. B plus 41i. Make sure you use the constant I here, okay? A plus 17i equals half plus root 3 on 2i. And another condition, and a squared plus 17 squared. That's a nice question. Equals b squared plus 41 squared, comma a, comma b. Yep. Two solutions, a value and b value. 65 root 3 on 3. And B equals 7 root 3 on 3. Yep. That's it. Okay, so that finished question 2. Let's look at question 3. A family of curves is defined by the differential equation dy dx equals minus 2xy. Plot the solution curve of this differential equation on the slope field below for the initial condition y0 is 1.5. So x equals 0, y equals 1.5. You are going to plot it accurately. In the middle, the slope is flat. And I guess this is what you're gonna plot on your paper. Yep. Label it as 0, 1.5. And I guess there is an asymptote y equals 0, horizontal asymptote, okay? Even though it's not asked by the question. Solve the differential equation above to show that y equals e minus x squared for the initial condition y0 equals 1. So dy dx equals minus 2x times y. Separating the variables, the left-hand side is 1 over y dy. The right-hand side is minus 2x times x dx. So you should have log e of y equals minus x squared plus c. You don't need to get any absolute value here because as y0 equals 1 greater than 0, log of absolute value y is log e bracket y, okay? When x equals 0, y equals 1, so log e of 1 is c. C is 0, so log e of y is minus x squared. Y is e to the power of minus x squared, as required. Okay, that's how you solve the differential equation, pretty easy. Then you want to find the coordinates of any points of inflection of the curve, given by y equals e minus x squared. So let's find the second derivative. Maybe solve. Let's do it in this way. Second derivative, e minus x squared. That's your second derivative. And let's do it in algebra, solve system of equations. Two equations, x and y. Y equals e minus x squared. And the second equation should be the second derivative equals to 0. So you have two sets of values. X equals minus root 2 on 2, y equals e to the power of minus half, or the positive root 2 on 2 and e to the power of minus half. Okay, so that is your full coordinates. d2y dx squared equals 4x squared minus 2e minus x squared equals 0. That is your first equation. Also, y equals e minus x squared. That is your second equation. Solving 1 and 2 for x and y. Notice that e minus x squared not equal to 0. X equals plus or minus root 2 on 2. Y equals e minus half. Therefore, the 2 points are written in coordinates form. Yep, that's it. Consider the family of curves defined by the differential equation. Y0 is 1 again. Okay, so this time it's minus kxy instead of minus 2xy. Use implicit differentiation to find d2y dx squared in terms of x and y. So we are actually differentiating both sides. Notice that your left-hand side will be the second derivative. Your right-hand side, you need to use product rule. 1 times y plus x times dy dx, okay? This is how you derive it using product rule. Minus k times y plus x times dy dx, which is this guy here, minus kxy, okay? Expanding it, you will get minus k. And y minus kx squared y. So this will be minus ky, 1 minus kx squared, okay? So this is your final expression for the second derivative in terms of both x and y. Hence, show that the y-coordinate of any points of inflection of curves in the family does not depend on a k. So for inflection points, d2y dx squared equals minus ky times 1 minus kx squared equals 0. But y equals 0 is an asymptote. So y cannot be 0. Therefore, 1 minus kx squared equals to 0, x squared equals to 1 over k, or x equals plus or minus 1 over root k. Now I want to use the x values to obtain the y values, but do we have the function? Not yet. Probably we look at the differential equation. The differential equation is dy dx equals minus kx times y. Y0 equals 1. That's the initial condition. Subject to y0 equals 1. In this case, I don't want to demonstrate all the integration process over again. So it will be a wise idea to use dsolve here. Y dash equals minus k times x times y. Space and space. Y equals, now y of 0 equals 1, comma x, comma y. Here we have y equals e to the power of half minus kx squared. Solving this dE, the particular solution is y equals e minus half kx squared. So the y coordinates are given by y minus 1 over k equals e half k times 1 over k, okay? Which is e to the power of minus half. Y of 1 over root k equals e to the power of minus half k times 1 over k, which is e to the power of minus half, which doesn't depend on a. Yep, because you can see in the final result for the y coordinate, it doesn't include k at all. So in the family, the y coordinates for any points of inflection does not depend on k. That is the intention of the whole question. Basically, you just use the previous part, equate the previous part answer to 0, and notice y is non-zero. You get the possible x values. And then to find the y values, you definitely want to find a particular solution to that differential equation, and it must satisfy this initial condition here. That's why I use the dsolve to obtain the function directly. And finally, you need to demonstrate your substitution process, which shows the y value, the same y value, independent of k values at all. Okay? So let's look at question 4. The position vector of a golf ball t seconds after it is hit is modeled by the position vector ATI plus BT minus 5t squared. Here, I suspect when they were writing the question, they used minus 10 as the gravitational acceleration rather than minus 9.8. But since the question is set in that way, we have to use what we have in front of us. A, B are z, which are integers. I is the unit vector in the positive horizontal direction, and j is the unit vector in the positive vertical direction. Displacement components are measured in meters. The golf ball is hit from the ground level, and after 4 seconds, it's 4 meters above the ground level and descending as it passes over the top of the tree. The tree is at a horizontal distance of 160 meters from where the ball was hit. So t equals 4, x equals 4. Hang on a second. X equals 160, y equals 4. Show that a equals 40 and b equals 21. So x equals at, t equals 4, x equals 160. 160 equals 4a. So a is 40. Show it. Then y equals bt minus 5t squared. T equals 4, y equals 4. 4 equals 4b minus 5 times 16. So 4b equals 84 and b equals 21. There we go. What acute angle to the horizontal direction does the tangent to the path of the golf ball make as the golf ball passes over the top of the tree? Give your answer in degrees correct to 1 decimal place. So your position vector r of t is 40t I plus 21t minus 5t squared j. To get the tangential direction, you just need to find the velocity and substitute the corresponding t value, which is the time at that point. So velocity is the time derivative of r, which is 40i, plus 21 take away 10t in the bracket multiplied by j. When passing over the treetop, velocity fall is 40i, and 21 take away 40, which is minus 19j, if I'm not mistaken. So once it passes over the treetop, the velocity is here. This is minus 19, this is 40. So we want to find the acute angle theta here, minus 90. Let's do a triangle here. Theta, 19, 40. So tangent theta equals 19 over 40. And you solve for that one, theta is tangent inverse. 90 over 40 times 180 degrees divided by pi. This should give you 25.4 degrees, okay? So that is the angle made by the velocity vector and the horizontal direction. What is the maximum height in meters reached by the golf ball? So we have various ways to tackle that part. But here, your height is only related to the j component, which is the y component, 21t minus 5t squared. If you complete the square for that one, let's do manual algebra. Complete the square, 21t. Take away 5t squared. Comma t. So when t equals 2.1, the maximum height is 441 over 20. Complete square. Y is 441 over 20. Take away 5t, take away 21 over 10 squared. When t equals 21 over 10 seconds, y max is 441 over 20 meters, okay? Alternatively, you could do the y dt equals 0. So 21 take away 10t equals 0. T equals 21 over 10. Then you substitute that t value into the y function here. You will get exactly the same answer as in the first method. Find the Cartesian equation of the path of the golf ball, giving your answer in the form cy equals dx minus x squared, where c and d are integers. So your x component is 40t, y is 21t, take away 5t squared. Now, if you use your CAS calculator, solve for t and y, solve 1 and 2 for t, y. Let's look at the result. X equals 40t. Y equals 21t. Take away 5t squared. So now you have these two expressions. T equals x over 20. Y equals minus x x minus 168 over 320, okay? But you want to express your answer in this way. So 320y equals minus x minus 168. And 320y, I suppose it's 168x, take away x squared as required. You have to satisfy the required specification by the question. So read the question and make sure you answer the question. A person is standing at a horizontal distance of 163 meters from where the golf ball was hit. The golf ball passes directly over the head of a person. If the person is 1.8 meters tall, how far directly above the person's head does the ball pass? Give your answer in meters, correct to 2 decimal places. The reason why they want you to find the Cartesian equation in terms of x and y is because if you draw a diagram to illustrate what's happening with the golf ball and the person, I guess this red line or this red parabola is the trajectory. Let's say y equals 168x take away x squared over 320. So the person is here. He is 1.8 meters tall. We want to find the difference here. This point has an x coordinate 163, but we don't know the y coordinate. So we sub in 163. Y 163 equals, let's use my CAS calculator. Now, very nice. We have this guy here. Substitute x equals 163. So the current height of the golf ball at this point is 163 over 64. Then we take away the height of the person, which is 1.8. The difference is 0.746875 exactly, but we just need to round it to 2 decimal places. So difference in height is 163 over 64, take away 1.8. Roughly 0.75 meters, okay? How far in meters is the golf ball from this person's feet when it hits the ground? So we use the diagram again. At this point, this is the unknown x, but the y value must be 0. So when y equals 0, 168x minus x squared equals 0. So x equals 0 or 168. This is where the ball hits the ground. So the difference in x, 168 take away 163, which is 5 meters. Yep. Pretty straightforward as a vector calculus question compared to the previous year's vector calculus question. Very easy. So let's look at the next question. Oh, a berry, a small round fruit of mass 0.025 kilograms, initially at rest, falls from a tree from a position that is 3 meters from the wall. Assume that the berry falls vertically and the only force acting on it is gravity. After 0.5 seconds, the berry hits the blank leaning against the wall. as shown below. The length of the plank is 5 meters, and it leans against the wall with its upper end at a height of 3 meters. Above the ground, which is horizontal, the plank and the path of the berry lies in a vertical plane. Find the distance that the berry has fallen when it hits the plank. Now let's draw a berry here, just in case. I couldn't find a berry. Where is a berry? Do we have a berry? Blueberry. Let's use a blueberry. And copy another blueberry, just in case. When it hits the ground, now hits the plank, 0.5 seconds. We can assume the constant acceleration, 9.8 meters per squared second. T is 0, U is 0 from rest. Yep, initially at rest. So this is my final displacement. T equals 0.5. X equals ut plus half at squared. Notice that I treat downwards as the positive direction. X is 0 times 0.5 plus half times 9.8 times 0.5 squared. So X should be, let me see. (49/4). 49/4 should be, hold on a second. No, this bit should be 0.5. Yep, 49/40. That makes much more sense. Or you could say it's 1.45 meters in decimal form. What is the speed in meters per second of the berry when it hits the plank? So V equals U plus AT. This should be 0 plus 9.8 times 0.5. V equals 4.9 meters per second, or you could say 49/10 meters per second. Show that the magnitude of the component of the velocity of the berry in the direction along the plank. In the direction along the plank at the instant that it hits the plank is 2.94 meters per second. In this case, if you really want to make sense of how we obtain 2.94, you need to redraw the diagram here. We know this is a right-angled triangle, remaining the ratio of 5:3. Maybe the horizontal is 4 if it's a right-angled triangle. So this bit, (3 meters), theta, 5 meters. When the berry hits the plank, that's at the end of stage 1. We just derived V0 is 4.9 meters per second, right? And if you draw this velocity with its two components in two directions, you could see this angle here. One direction is perpendicular to the plane, to the plank. Another direction is running along the plank, running along this plane. So I guess this side is sine theta, this side over that side is sine theta, and this perpendicular side over the velocity is the cosine theta. I guess V parallel is V0 times sine theta. In this case, this is 4 meters. So it will be 4.9 times 3 over 5, which is 4.9 times 0.6. And it should give you 2.94 meters per second, indicating the horizontal component of the velocity. All right. The berry does not bounce or deform, but immediately begins to slide down the plank with an initial speed of 2.94 meters per second, subject to gravity and a constant resistance of magnitude R newtons. Okay, it's a friction force, R newtons, that oppose the direction of motion. The berry reaches the end of the plank at a speed of 1.06 meters per second after 2 seconds. Find R. So, because all forces are constant forces, we can use Suvat. A, the acceleration during this stage is V minus U over T. So it's 1.06 take away 2.94 divided by the time difference 2. And this should be minus 0.94 meters per squared second. Now we need to borrow the previous diagram. I believe I just need this bit. Without the diagram, I couldn't do any, understandable calculation. Now from here to here, I just need to draw all possible forces. This is the 0.025 G, the gravitational force. That is my reaction force. Opposite to the direction of motion here. Oh no, I can't use R because R is the letter here. I'm using N. This is R. So now I'm decomposing the gravitational force. This is theta. This is 0.025 G times cosine theta. And this is 0.025 G times sine theta, the parallel component of the gravitation force. So F net is equal to 0.025 times 9.8 times 3 over 5. Take away R. This is MA, 0.025 times 9 times minus 0.94. This is your mass times acceleration, driving force, retardation force. So now I just need to solve for this equation, solve for R here. All right, let's call for my CAS calculator. 0.025 times 9.8 times 0.6, which is 3 on 5, minus R equals 0.025 times minus 0.94, comma R. Okay. Looks like We should have something different. Okay, so what I obtained from this equation is 341 over 2000. Or you can say it's 0.1705. Probably I need to keep the exact value here in newtons. Okay. Finally, we want to find a horizontal distance d meters from the wall to the initial position from which the berry began to fall. So we noticed from here, let me redraw the diagram. Right. So this bit is u equals 2.94. At the end, v is 1.06 meters per second. So now I can find the distance traveled. X is u plus v over 2 times t, which is 2.94 times 1.06 divided by 2 times 2. This should be 4 meters, okay? Now, with this triangle here, I know the distance it traveled from this position to this position is 4 meters. The distance d meters from the wall is here. This is 1 meter. So I'm going to use d here. This is the whole distance from here to here is 4 meters. So this bit is 4 minus d. Using trigonometry or similar triangle. So it's 4 over 5 equals 4 minus d over 4. You can solve for that equation. D equals. So let's look at the CAS calculator. D is 0.8 meters. Okay, now question 5 finished. Question 6. A real estate agent's income is comprised of a fixed monthly payment of $5,000 plus a commission of $4,000 for each house sold. The agent may sell up to 3 houses in a month with the following probability distribution, where H is the number of houses sold. Find the agent's expected total income each month. Give your answer in dollars correct to the nearest dollar. So the expected income, let's say it's I, okay? I equals the base salary, $5,000 each month, plus 4,000 times H. Using that idea, we could say the expected income is the expected income 5,000 plus 4,000 times the number of houses. So it's 5,000 plus 4,000 expected number of houses. Now I could use expected number of H, that is 0 times 0.2 plus 1 times 0.6 plus 2 times 0.19 plus 3 times 0.01. And this should be 0, 0.6 plus 0.38 plus 0.03. 1.01. So the expected income should be 5,000 plus 4,000 times 1.01. This should be $9,040. Correct, the nearest dollar. All right, so that is my expected total income each month. What extra amount of commission should the agent request for each house sold so that their expected monthly income increases by 2,000? Give your answer in dollars and cents, correct to the nearest cent. Okay, so the new expected income should be 9,040 plus 2,000. We know the fixed payment of 5,000 will not change, but the commission increased by, let's say, $C. The expected value of house, EH, will not change. So 1.01 is still here. Now we are solving that equation for C. Let's see what happens. Looks like I need $1,980 plus 19 cents, or actually 20 cents, because I need to round up the 8. That should be the correct extra amount of commission paid for each house. Okay, so let's look at the next one. To prepare a certain house for sale, the agent recommends that the garden be landscaped and replanted. The time taken for a contractor to landscape the garden is normally distributed with a mean of 18 hours and a standard deviation of 4 hours. Okay, so landscape is normally distributed 18 hours, and the next standard deviation is 4 hours. Make sure they are in the same unit, okay? Both are hours. The time taken for the replanting is independent of the time taken for landscaping and is normally distributed with a mean of 24 hours and a standard deviation of 6 hours. So replanting is normal distribution, 24, variance is 6 squared. What is the probability, correct to 4 decimal places, that the garden can be landscaped and replanted within a week? Assume that the contractor will work 8 hours per day for 5 days of the week. So 8 hours per day for 5 days of the week. 1 week, we only have 8 times 5 equals 40 hours. We must make sure the time for landscaping and the time for replanting is less than or equal to 40 hours. So we need to find a combined variable between L and R. Let T equals L plus R. the expected value of t is 18 plus 24, which is 42. The variance of t is 16 plus 36, which is 52. So the standard deviation of t is square root of 52. If you like, write it as 2 root 13. So probability of t less than 40, less than or equal to, that will be a standard normal random variable, z smaller than 40, take away 42 over 2 root 13. I guess I need to use normal CDF, probability distribution, normal CDF. Probably the time must be greater than 0, but less than 40. 42, that is the combined mean value, and square root of 52, that is the combined standard deviation. All right, so 0.39075557. Okay, so it's 0.3907557, blah, blah, blah. 4 decimal places, 0.3908. Finished. Okay, so what period of time should the agent allow the contractor to complete the task of landscaping and replanting in order to be 90% confident that these tasks will be completed within this period of time? Give your answer in hours corrected 2 decimal places. So now we know the combined variable t is normally distributed with mean 42, and the variance is 52. If we sketch a rough normal diagram, we know this area should be 0.9. So we try to find, let's say, this is t. Probability t smaller than or equal to t equals 0.90. T is approximately equal to what? Left tail, that's good. Inverse normal, let's say 0.9, 42. Root 52, 51.24. Hours. Okay. Before the annual income review, the agent believes that the company's remuneration level is below, look at this word, the industry average of 115,000 per annum, with an industry standard deviation of 12,000. To test this hypothesis, the agent takes a random sample of 36 of the company's employees and find the mean income to be 110,800 per annum. So let's list them. Mu0 is this industry average here. X bar is this number here. Calculated from 36 employees, and the population standard deviation is 12,000. Our alpha level is 0.05, okay? So, one-tailed statistical test. Okay, so let's see. H0 is mu equals 115,000. H1, we are testing it against less than the claimed value. So our X bar is this guy here. Sigma is 120,000, and it's 36. My p-value is probability X bar less than that value, given that mu equals 115,000. So it's given by z less than 110800. Take away 115000 divided by the standard deviation of 12,000 divided by square root of 36. Very tedious. It's not necessary for you to write everything in this statement. You can just use menu 671 to complete all these tedious calculations. I'm just demonstrating each possible step for you to refer to later. All right, so what I obtained from these p-value expression is 0.017864. And the important thing I'm going to do is compare this p-value with the level of significance. Since p-value is approximately 0.017864, but it's way smaller than 0.05. So we have sufficient evidence to reject H0. Or we say we should reject H0. But finally, we have to answer the question, is this sample mean supports the agent belief? So what is the agent belief? The agent's belief is the company's remuneration level is below the industrial average. Yep, it is below the industrial average. As the sample means suggest that the remuneration level is below the industry average. Too low. The sample as certains the agent's belief. To gain full mark for this question, you have to really answer, really nail the detail of the requirements, okay? Answer the question. Does it support the belief or not? Not just explaining p-value less than 0.05, or you just simply state to reject H0. If you are just up to this point, you are not fully answering the question, okay? So that's it for the immediately past 2021 Northern Hemisphere timetable, Specialist Math Exam 2. And I'll see you next time. Thanks for watching. Bye-bye.